Hi everyone, I'm Padma Priyan, PhD student from University of Queensland. Here I'm going to present one of the posts that I'm doing as a teaching assistant. It's called Digital Design, specifically for electrical and computer science students and fourth year students. So here I'm going to present the work on behalf of my course coordinator as well as supervisor Shamit Vijayanayaka. He's doing these courses currently in University of Queensland. So digital design specifically targeting the students who try to make it the circuit level designs, and traditionally it has been like taught by how the hardware look like, and they have to code it by themselves. And like as you see here, this is one of the simple adder designs. So but simple adder, they have to line bunch of codes with the syntax and they have to follow it. So the especially first in the beginning, they have to teach how to do that. Now existing there are many existing tools in the market that can be useful to replace this bunch line of code with the simple blocks, and they can say stuff the constraints, how many bits and everything, and what are the other results we can obtain. We can see that through the code itself. So now what we are using is we are optimizing these tools to move from traditional method to the model based design. So then finally from the model itself, we can generate the automate codes. So carefully what we are doing is we are choosing some different research problems, like specifically starting with the simple filter designs and then move towards trigonometric transform, DCT, DFT, and that can be useful in the image compression and multiform form. So from this onwards, students can get exposure related to some contemporary research areas. So now the main question is why we need model-based design. There are many technical details. I don't want to go to that level, but I will clearly explain the first thing. So it is a simple filter design. If they want to code it by themselves, it will make the simple multiplier add and then have to create a hierarchy. Instead of that, if we can do the model-based design, by looking at that, they can easily optimize something like from this level to this level. With their knowledge, they can come up with some timing related analysis and the quantizations and how they can do that, everything within the model itself. So from this onwards, students will easy to learn this kind of courses, and they are better to come up with how to map the algorithm to architecture and how they can relate the hardware software, and they can easily finally with a low level FPGA development. So we evaluated this with the fourth year undergraduate students and in the University of Queensland. Finally, we are delivering this with the best effective for model based level design.